Okay, in this video, I am going to solve a sample problem about moment of inertia. Here's the problem. For the plane region with the circular cutout, letter A, find the moment of inertia with respect to the x and y axis. And letter B, compute the centroidal moment of inertia Ix bar and Iy bar using parallel axis theorem. Okay, so first, let us know the different elements or basic figures for this composite figure. So we have the square 30 by 30 plus a semicircle and then plus an equilateral right triangle and then minus a circle with radius 15. Okay, so we get the moment of inertia of the square plus the semicircle plus the triangle and then minus the circle. So first we compute for the moment of inertia with respect to the x-axis. Now let's recall from the formula, this one. For a rectangle or a square, the moment of inertia with respect to its base or the x-axis is equal to 1/3 bh cubed. Okay, so we have this one. 1/3, the base is 50, height, the base is 30, height also 30. Plus semicircle, element number 2. For a semicircle, this is the x-axis. But based from this figure, ang x dere, same ra sa y dere. So ang y-axis here is equal to this one, the x-axis sa problem. And our IY is pi over 8 times r raised to 4. So pi over 8 times radius 30 raised to 4. Okay. Plus triangle. Okay. For a triangle, okay, the moment of inertia with respect to its base, this one x, base is equal to 1 over 12 bh cubed. Base 30, height 30 also. And then minus circle. So for a circle, the moment of inertia with respect to x, this one is equal to pi over 4 times r raised to 4. Okay, so you compute the total is this 615,825.4742 millimeters raised to 4. This is the moment of inertia with respect to the x-axis. Okay. Next, moment of inertia with respect to the y-axis. So we start again with the square now. For a square or a rectangle, moment of inertia with respect to y is 1/3 b cubed h. But since this is a square, b is equal to h. So 1/3 b cubed times h. 1/3 b cubed h. Plus, for a semicircle, ang y-axis niya, equivalent sa x dire. Since lahi ang orientation, the orientation is different, no? So, ang y there is a problem, x there is a formula, ada sa figure na, ada sa formula. Ano na figure? X. So, pi over 8 lang. Pi over 8 r raised to 4. And then plus triangle. For a triangle, the moment of inertia with respect to y is 1 over 12 b cubed h. Base 30, height 30. 1 over 12 b cubed h minus circle Iy is also equal to pi over 4 times r raised to 4. and you compute, the total is this one. 615,825.4742 millimeters raised to 4. Same with IX. Okay. Now, in order to compute for the centroidal moment of inertia, first that you will do is locate the centroid. Okay, because you will be using parallel axis theorem. Okay. So first, we are going to locate the centroid. Okay, these are our elements: square plus semicircle plus triangle minus circle. Okay. Okay, let's locate the centroid of each element. For a square, it is located at its geometric center. So x is 15, y is also 15. So x1 for element 1 is 15, y1 is also 15. Now, for the semicircle by symmetry, the centroid is located along the x-axis. So, example, here. So, y bar is equal to, y sub 2 is equal to 0. So, we only compute for x sub 2. Okay, the centroid of a semicircle is 4r over 3 pi. Also, the radius is 34r over 3 pi. It's 40 over pi. But when we substitute this one to the Varignon's theorem, we put negative sign since the point is located on the negative x-axis. Okay. For a triangle, this is x3. And since the point is located on the fourth quadrant, the x-coordinate is positive, while the y-coordinate is negative. Okay. So, x3 is 1/3. 1/3 of 30, which is equal to 10. And y sub 3 is 1/3 also. 1/3 of each equal to 10 also. Okay. And for a circle, of course, the centroid is at the origin. Okay, so we construct a table and then we supply values. A1, area of element 1, it's 30 by 30 is equal to 900 plus area of a semicircle pi r squared over 2, 450 pi. Area of a triangle 1/2 BH, 450, and area of a circle pi r squared, negative. And add area 1 plus area 2 plus area 3 minus area 4. The total area is 2056.858347. And then we supply the values of x and y. x1, 15. y1, 15 also. A sub 2, x is negative 40 over pi. While y sub 2 is 0. X sub 3 is positive 10. Y sub 3 is negative 10. And for element 4, 0. And y is 0. For this column, it's the product of x and a. So 15 times 900, 13,500. Negative 40 over pi times 450 pi. 450 pi. Negative 18,000. 10 times 450. 450 times negative 225 pi is 0. And so we add 13,500 minus 18,000 plus 4,500 plus 0 is equal to 0. Next, for this column, y times a, y times 15 times 900, 13,500, 0 times 450 pi is 0. negative 10 times 450, negative 450 times negative 225 pi, it's 0. And then we add, the total is 9,000. So from here, we can now compute for the centroid, the location of the centroid, x bar and y bar. So this one, we solve for x bar. It's 0 over 2056.858347. And it's equal to 0. X bar is equal to 0. For y bar, we substitute 9,000 over total area. The value is 4.375605.162. Okay. So after this, we can now compute for the centroidal moment of inertia. Okay. So this is our composite figure. Okay. Okay. Nadiri ang centroid. X bar is 0, therefore, nasa y-axis no x bar. Y bar is this. Y bar is 4.375605.162. So this is x bar, and then x bar is 0, y bar is this. Okay, so this is the location of the centroid of element 1. Element 2. For element 3, nadere. And the element 4, nasa origin. Okay. We need these points to determine the value of D sa parallel axis theorem. Now, to get this distance, okay, the value of this one is 15, okay? 15. 15. Y1 is 15, okay? So this is 15 minus Y bar, okay? So that's 15 minus Y bar, and that is equal to 10.6243948838. This one, this is D3, okay? That's 10 plus Y bar because this is 10, no? 10. For a triangle, this is 10. 10. So 10 plus Y bar. That's D3, okay? Now for D2, this is D2. And that is Y bar. Okay? For element 4 circle, D4 is this. D4. Y bar yapon. Now, this is our parallel axis theorem. Centroidal for each element plus AD square. D is the distance between the two axes. So, like this one, D1. This distance, the value of D is the distance between the centroidal axis, this one, okay, and this one, the centroidal axis, and then this axis, D1. For D3, D3 is the distance between this centroidal axis and this axis, D3. So with D2 and D4, no? So i-add tanan, but since isubtract ng circle, then isubtract sad nato ang moment of inertia. Okay. So let's recall. Okay. For a square, okay, the centroidal value of I is 1 over 12, no? With respect to the centroid, okay, the centroidal bar, 1 over 12 BH cube. 1 over 12 BH cube plus area sa square, which is 900. So 1 over 12 BH cube plus 900 times D1 squared. This one. 1/12 BH cube plus area times D1 square. Next is semicircle. Now, sa semicircle, okay, Ix is this one. Okay, Ix. But based sa figure, ang x dire sa problem is equivalent to y dire. Since different ang orientation nila. No? So, ang x dire, ang Ix is equal to Iy dire. And our Iy is pi over 8 r raised to 4. And so we will use pi over 8 r raised to 4, no? Ang Iy. Bale dire, ang Ix bar lang na ang Iy bar is the same as Iy. Ang Iy bar. O I sub y bar. Same lang sa Iy. So we will use pi over 8 r raised to 4. Plus area, the area is 450 pi. And then times distance. The distance is y bar. Distance between the two axes. This centroidal axis and this axis. Y bar. Okay, we have this one. It's pi over 8 r raised to 4 plus area y bar. Now, for number 3, for the triangle, let's recall. For a triangle, the moment of inertia with respect to its centroid, this one, is equal to this. X, Ix bar, 1/36 BH cube. So, it's 1/36 BH cube plus area. Area of the triangle is 450. And then distance, D3 square. So 1/36 BH cube plus area D square. And then we subtract circle. Okay. For a circle, I is the same, no? Centroid and origin, same lang. So, the centroidal moment of inertia is still pi over 4 r raised to 4 plus area niya. The area is negative 225 pi. Okay. But since we use bracket, plus lang yapon. Plus area. The distance is this, y bar. Kaya sa circle, nadiri ang centroidal axis and then centroidal axis sa whole area. So the distance between the two axes is y bar. Okay. So instead na mag-negative ka, naka-bracket man, so mag-plus ka. Anyway, if you remove the bracket sign, negative times positive, negative gihapon. Okay, so compute all the terms and sum up. The total is this. So this is the value of the centroidal moment of inertia with respect to moment of inertia with respect to the centroidal x-axis. Okay. Next, Iy bar. Okay. Moment of inertia with respect to the centroidal y-axis. So again, we compute for D. Ang D sa formula sa parallel axis theorem is distance between the two vertical axes. Like for this one, for element 1, this is the centroidal vertical axis. The distance of this one and the centroidal y-axis of the whole area is 15, since the centroidal axis coincides with the y-axis. So, therefore, ang D nato is 15 lang. Okay, 15. Okay. For D2, it's negative 4r over 3 pi. This one, 40 over pi. For 3, it's 10, no? This one, no? 10. And 4, 0. Okay, D4 is 0. Okay. So again, this is the parallel axis theorem. Okay. Recall. Sige. For a square or rectangle, the moment, centroidal moment of inertia with respect to y, this one, is 1 over 12 b cube each. And then plus area times d square. Next. Okay. Another entry can apart. Semicircle. Now, for the semicircle, this is the centroidal y-axis. No? Centroidal y-axis. Now, if you look at this one, this figure, ang centroidal na y-axis dire is equivalent to the centroidal x-axis anin na figure. Okay? Ang centroidal na y dire equivalent sa centroidal na x dire. Therefore, ang gamiton nato na value for IG centroidal is this one, 0.1098 r raised to 4. Centroidal, and then plus area niya d square. Naka-round off din na value. But if you use parallel axis theorem, this is the correct value, 0.109756966 without rounding off the value. So this one, r raised to 4 plus area niya d2 square. Okay. Plus triangle. So sa triangle, the value of IY bar is 1 over 36 B cube each. Plus area, and then D is 10. And then circle, pi over 4 raised to 4 times R raised to 4 plus area, but then our D is 0. And so you add up, compute, and then sum up. This is the total value of moment of inertia with respect to the centroidal y-axis. Okay, so I hope that you have learned something from this presentation. Thank you for watching.